Hey, good night, or good night. Oh boy. Good evening, Nighthawk Nation. Hey, I was looking at Module 1, Module 2, Module 3, and I thought instead of having you download all these PowerPoints, I thought maybe I could walk through them with you and take a look at them with you real quick. So, with that being said, I'm going to share my screen, and that way you'll have them all just with one click, and you won't have to go through and download all of them. So chapter one, uh, we're going to discuss the informatics, disciplinary science, and foundation of knowledge. Um, at the end of this module, you should be able to define exactly what health informatics is. And this is going to be a very important module. A lot of what you find in chapter one and chapter two, you'll find on upcoming quizzes. You'll find on the exam, and it's information that you're going to cover throughout the remainder of your health informatics degree program. And so I definitely want you to take heart and really look at how we define health informatics, uh, be able to illustrate the relationship between disciplinary science and informatics, the know the foundation of knowledge model, explain data information and knowledge wisdom paradigm, and establish a healthcare professional as knowledge workers. And these are things you should be able to define and know at the end of this. Some of the building blocks of informatics, we look at disciplinary science, computer science, information science, and cognitive science. Um, as a hint, these will be on a quiz and on an exam. And so you definitely, without question, want to know these four items. The one that you're going to look at and probably use the most throughout your professional career, I would say, is going to be information science and cognitive science. Um, you're going to be looking at data, you're going to be handling data, and cognitive science. That just goes without saying. Why should we study informatics? Well, healthcare information is intensive. Um, Interprofessional collaboration and communication are essential for care coordination. Technology tools help us collect, integrate, and manage clinical information. And so when we look at electronic health records, this is what it's referring to when interprofessional collaboration and communication, you know, as informatics specialists, sometimes we're able to see trends or things that are happening that maybe the medical personnel is not seeing. And so that it's a very, very important tool for us to look at to understand. I'll put this in the presenter view. Maybe that'll look a little better for us. Um, we also need to know the science of information management in healthcare. Uh, all healthcare workers, regardless of discipline, need a basic understanding of informatics principles, how data, information, and knowledge are used in discipline. How does this understanding promote wisdom in practice? And basically, what this is referring to is we need to understand health informatics, the data that's involved, the trends that are found, no matter what profession we're in, whether we're nurses, whether we're front office, whether we're physicians, physical therapists. This is all information that we need to know. Some of the core elements of informatics, as we spoke about earlier, the DI-KW paradigm, the foundational disciplinary knowledge based on the foundation model, and then informatics competencies needed by all healthcare professionals to practice in the 21st century healthcare environment. Um, we all need to know how to run data, pull data, look at trends, how to handle the electronic health records, how to make sure that we are not violating any of the HIPAA laws, how we're keeping an individual's health records private. These are all these cannot be underestimated or undervalued. When we look at the DIKW paradigm, we are looking at raw facts when we pull data, data that has been interpreted for meaning. And then we look at the awareness and understanding of a set of information in ways that information can be made useful to support a specific task or arrive at a decision. This comes back to looking at the data, and looking for trends, looking at things that we see that might be happening or things that aren't happening any longer. And so we need to go in another direction. And that's what this is referring to. Describe a scenario in your discipline where you use data, information, knowledge, and wisdom. And so I want you to be able to do this. This is something um, that, let's say, in our semester-long project, this might be a scenario that you have to discuss. And so I want you to be able to do that. I want you to know what it is you're doing with the data, what it is you're doing with the information, and how you're compiling all that. And so when we talk about thought-provoking question, that's what this is referring to. We need to know how to use the knowledge. Individuals have an amazing ability to manage knowledge. The ability is learned and honed from birth. We know, and it sounds simple, but when we're hungry, we cry and we get fed. And so we're taking information and we're gaining knowledge on how we can satisfy our hunger, even as children, as infants. And we build on that. We learn how to read, we learn how to do math. And so we also experience our environment and learn by acquiring, processing, generating, and disseminating knowledge. And this is the use of knowledge. Um, the more knowledge we have, the more information we have, the more we know what to do with it. The foundation of the knowledge model, it's organizing conceptual, excuse me, framework for text. It helps to explain the ties between disciplinary science, informatics, and knowledge. And informatics is viewed as a tool for founding knowledge. We're going to use informatics as a way of putting all our information, all our knowledge together. And if you look here, you can see an example of the foundation of knowledge module. There's more detail in our book. Let me tell you what, I am looking at it right now, and it's on page 10 of your book. And so when you go in there and you look at page 10 of your book, you'll get a fantastic description of exactly what this is. Healthcare professionals and knowledge. Healthcare professionals are knowledge workers. We handle information, we disseminate data, we disseminate information, we take that, combine it with wisdom, and have knowledge. We work with information and generate information, and as knowledge is a product, we provide convenient and efficient means of capturing and storing knowledge. We benefit from the valuable, viable knowledge, and we design, develop, and implement methods of maintaining knowledge. Um, we and we also have the ability to capture and process collective expertise and distribute it where it can create the largest benefit. This comes back to looking at data and finding trends. This can't be understated. In the pandemic, the research and the trends and the data that we were able to do to prevent something like this on the scale that it happened, it's invaluable. Let's see. Learning worker is very important for you to know. It's one who has the ability to learn quickly and continuously, a designation that may surface more frequently as healthcare organizations transition to learning organizations. As healthcare workers, we're going to be learning something new every day with AI and with the advancement of medical technology, medical healthcare. It's the importance of us learning quickly cannot be understated. Knowledge viability. This refers to the technology-based applications that offer easy, accessible, accurate, and timely information obtained from a variety of resources and methods, presented in a manner as to provide us with the necessary elements to generate new knowledge. This is where we're using technology to pull information, data, and what have you, and creating new knowledge so we can get ahead of negative trends, we can get ahead of pandemics, things of that nature. And hopefully we don't have another pandemic, but you just never know. Healthcare professionals have the opportunity to be involved in the formal dissemination of knowledge via their participation in professional conferences. I can't tell you how important it is for you as a healthcare professional to attend conferences. These are typically academic, but you will learn new and incoming technologies, new trends. You'll meet peers who are learning and studying the same things you are in the same industry you are. I can't begin to tell you the importance of professional conferences or academic conferences and presenting and attending. I would be more than happy to help anyone out there in doing so. The use of wisdom is the application of knowledge to an appropriate situation. So this is where we're taking everything and we're tying it up with one big bow and we're using it to benefit our stakeholders. And if you were in Health 2100, we discuss stakeholders as the main stakeholder being patients or consumers. And that is our job, is to make the lives of our patients better. And so that's where this comes into play. Uh, this was an option, so we'll bypass that one. This was an option for your discussion post. Some of the informatics competencies in informatics competency is the knowledge, skill, and ability to perform specific informatics, health information management. And that's what we're going to learn to do this semester and forthcoming semesters within the program. A HEMA task force. There's 5 domains for informatic competencies for all healthcare workers: health information literacy, health informatics skills using EHR. By the time you finish this program, your knowledge of electronic health records should be second to none. And so that's what this is referring to. The importance of privacy and confidentiality of health information. Um, it's so important that we maintain the trust and that we secure the privacy and confidentiality of health information for our stakeholders. Health information, data, technical security, basic computer literacy skills. I think we all have that. But when it comes to the health information, data, technical security, and the privacy and confidentiality, the importance of that cannot once again be understated. And so let's go on to second set. Maybe. So when we look at chapter 2, it's an introduction to information science, and information systems. I started to explain a lot of this in the first set of slides, but then I was thinking, oh, it's going to come up. So by the end of chapter 2, we're going to reflect on the progression from data to information knowledge. We're going to understand what information is, assess how information is acquired, explore quality information, describe the information system, and explore data acquisition. I'm going to run through these slides a little faster because we still have one more set of slides, and I don't want to talk you to death here. But you also need to know the outputs or reports, document summaries, alerts, outcomes, etc., that we will produce as health informatics specialists. Describe information dissemination, define information science, intent, assess how information is processed, and explore how knowledge is generated. These we looked at just a moment ago when we talk about data. Oh my gosh, you can tell it's been a long day. And when we talk about data, we're referring to raw facts. Data integrity refers to the whole, complete, correct, and consistent data. This can be compromised through human error, viruses, worms, other bugs, hardware failures, crisis errors, or hackers entering the system. It can also be how we disseminate data. There can also be a compromise. We have a tendency to get rid of certain data because it doesn't fit within what we're looking for, and that's something that we never need to get into the habit of doing. And we'll cover that later on as well. Data that is relevant and accurately represent corresponding concepts. Data that is dirty when these are errors in the database, such as duplicate, incomplete, or outdated records. And we'll discuss this later on as well. The data that we process into information must be of high quality, integrity to create meaning, to inform our assessments and decision making. This is everything that goes into high quality data. When we refer to data as being dirty, where there's errors in the database, such as duplicates, incompletes, or outdated records, maybe when we entered some information, we didn't enter all the information, or a patient didn't give us all their information, or for whatever reason we entered something twice. And this can skew data when we're looking at trends or when we're looking at a patient's record. It can skew the information that we have in there. So the importance of what's called clean data, making sure that there's no holes in the data, that everything is completely filled out and all duplicates are removed, is very important. The quality information necessary for it to be valuable and meaningful. If we have a lot of information that really has nothing to do with anything, it's not something that we need to spend our time looking at, because our job in health administration or health informatics is to better the lives of our stakeholders, and our number one stakeholder is the patient or the consumer. Information of science. Science of information is the studying, the application, and usage of information and knowledge in organizations, and the interfacings or interaction between people, organizations, and information systems. Information science enables the processing of information, a multidisciplinary science that involves aspects from computer science, cognitive science, social science, communication science, and library science. And when we combine all those subcategories, we come up with one big one called information science. Information science deals with obtaining, gathering, organizing, and manipulating, managing, storing, retrieving, recapturing, disposing, or distributing and broadcasting information. So basically, information science, we are looking at what information we need to keep, what we don't need to keep, what data we need to keep, what data we don't need to keep, and what it is we need to do with it. The conversion of latent information into manifest information. Latent information is that which is not yet realized or apparent. So we're looking at data, we're running, and we're looking at trends, but we haven't found them yet, or we haven't seen it yet. So that's what that's referring to. Information systems, or IS, is the combination of hardware, software, and telecommunication networks that people build and use to collect, create, and distribute useful data. And so when it's referring to information systems, we're just looking at everything that we use to create and pull data in a nutshell. Information systems acquire data or inputs, processes data, and this is what we use to run reports, create alerts, prompts, what have you. And it's this portion of the information system that when we provide the data and that we're using to pull reports. Did I just say that? I did. Need more caffeine, or less caffeine maybe. The information systems also provide the capability to disseminate, provide feedback, and adjust the data information based on these dynamic processes are what sets them apart. They should be a user-friendly entity that provides the right information at the right time in the right place. Even your laptop or your iPad can be considered an information system. You're putting information in, you're using different programs within it to get outputs or reports, whether it's Microsoft Excel, Microsoft Word, SPS, PLS. There's all kinds of different programs out there. But we have a lot of options or opportunities when it comes to information systems. And so I'm going to jump out of the slide 2 and we'll jump into slide 3 and then we'll be done. And you can go back your way and you can stop listening to Dr. H talk so much. Let's put this in presentation mode. I should have done that the last time. I didn't think about it. So computer science and the foundation knowledge model. So at the end of this chapter, and you are covering a lot of material in this first module, but you're going to use the information that you learn and the knowledge that you gain and the wisdom you gain in these first 3 chapters you're going to use throughout the semester. So just keep that in mind. You should be able to describe the essential components of the computer systems, including hardware and software, recognize the rapid evolution of computer systems, analyze how computer systems function, define the concept of human technology interfaces, articulate how computers can support, collaborate, networking, and information exchange. The discipline of computer science is introduced through a focus on computers and the hardware and software that make up these evolving systems. Computers is a tool for managing information and generating knowledge. This one's almost self-explanatory, really. We use, and a computer is nothing more than a machine that provides input and output. We give the data or the information, we put that into the machine, even if we're using artificial intelligence or AI, there's still a human component there. Um, and it's described, the computer system itself and everything that goes into it. You can see here on figure 3-2 under computer components. Um, Leave there just one second. You can always come back to this if you need to. The slides I will leave in the unit as well. Acquisition of data and information or input components. Input devices include, hint, hint, this is on your quiz coming up. Input devices include the keyboard, mouse, joystick, game controllers, pads, web cameras, styluses, image scanners. The one that we need to really focus on here, hint, hint, would be keyboard or mouse. These devices are the origin or medium used to input text, visual, audio, or multimedia. The two primary input devices of the computer are the keyboard and mouse. Processing of data information. Believe that should be throughout or processing component. Specific software is used depending on the application and data involved. Um, you'll have a course coming up where you'll use Excel, and from there you'll learn R, and many of you may already use SPSS. If not, you will. In the world of academics, SPSS is probably the leading item. Leading program, excuse me. Microsoft Word is another one of these, but numbers if you're using a Mac. But that's what it's referring to when it's referring to software. Output devices carry data in usable form through exit devices or attached to a computer. For example, printed documents, video files, summaries, DVDs, flash drives, CDs, boy, howdy, external hard drives, etc. Cloud computing is become the number one source of storage for information and accessing data and programs via the internet. Um, we can store so much more on the cloud than we can in actual computer hard drive. And in many cases, there's more security built in due to encryption programs. And so you'll want to learn cloud computing, hint, hint. Also, the relationship of computer science to knowledge. Scholars and researchers are just beginning to understand the effect of the computer systems architect, applications, and processes have for potential knowledge acquisition and development. And we're really seeing this now with AI. We're really seeing a boost and a jump in information and knowledge being gained and learned through computer systems. We're learning how we're able to contribute to the development of knowledge through the use of productivity, creativity, and communication software. So make sure that chapter 3, when you get to this section, pull out your highlighter and highlight away. What is the relationship of computer science to knowledge? Using the web, you like that, the World Wide Web. Users are also able to disseminate knowledge on a grand scale with other users. We're able to share data and find data now that 20 years ago just was not fathomable. And so it's pretty amazing. The deluge of information available via computers, it needs to be mastered and organized by the user of knowledge to emerge. And so we have to know what we're looking at, and why we're looking at it. Um, Discernment and the ability to critique and filter this information must also be present to facilitate further development of wisdom. We can't just pull anything and everything and just throw it into a report. We have to have the wisdom and the ability to know what it is we're looking for and why. And just to wrap it up, the field of computer science is, I would say, saying it's the fastest growing discipline. It is the fastest growing discipline with the emergence of AI, with the emergence of cybersecurity. Everything is electronic. Uh, all medical industries by 2030 must be electronic. And I'd be shocked if there were still offices operating off paper, but I'm sure somewhere there is. And so this just kind of wraps up the 3 set of PowerPoint slides. That way you don't have to download each individual slide. We can kind of run through them here together. You've got my ramblings and some of my explanations. If there's anything that I did not explain or explain well enough, please reach out and I will help you with that in any way I can. Other than that, Nighthawk Nation, let's stop the share. Other than that, Nighthawk Nation, I want you to have a wonderful semester, and I look forward to speaking to you again. Dr. H is out. Bye.